Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic we're going to discuss the Brent-Dekker method. In this topic, we will discuss the weaknesses of some of the previous methods that we've seen, and we'll consider an algorithm by Dekker, later modified by Brent. We will see how this uses three bracketed techniques, but it ensures a faster convergence than any of them individually. Now, unfortunately, this is the Brent-Dekker method and not the Bryant-Deckard method, which would have been really nice, but c'est la vie. Now, the bisection method only halves the interval size when searching for a root. The bracketed secant method gives a better choice, approximating the root. However, unfortunately, the algorithm ends up usually fixing one of the endpoints, and thus it is reduced to linear convergence. Dekker's method suggests combining and alternating between the bisection and bracketed secant methods. Simply alternating between these two algorithms significantly increases the rate of convergence of the bracketed secant method, and an intelligent choice as to which method to use can lead to even better convergence. The problem is, once a function is near the root and is only either concave up or concave down on the interval in question, one endpoint of the secant method becomes fixed. Inserting applications of the bisection method unfixes this endpoint. Now, Brent, in his 1993 text, Algorithms for Minimization Without Derivatives, details an alternative algorithm that alternates between the bisection method, the bracketed secant method, but also the inverse parabolic interpolation method. This results in a superlinear convergence technique, but one that is bracketed, which means that it will also guarantee convergence to that root. A number of conditions are used in Brent's algorithm. Ideally, it is going to use inverse parabolic interpolation, but this technique for an individual step may be determined to be suboptimal. It tries to fall back on the bracketed secant method. However, this too may be suboptimal, in which case it reverts to using the bisection method. Now, Brent's text is actually available on his website as a PDF, and you are welcome to search for and download this text for your own personal reading and hopefully enjoyment. At the end of chapter 4, we have an implementation of this algorithm in the ALGOL 60 programming language. You are welcome, of course, to try to translate this into C++ or any other language of your choice. Now, this is the first algorithm in the course that we have seen that has been written in the last half century. That is, one that has been written within the lifetime of your grandparents, if not your parents. We're going to see two other algorithms within this course that fall within that time span. The Dormand-Prince algorithm, and later an algorithm that is called Brent's algorithm, or Brent's method, for minimizing a function. The Brent-Dekker method is the basis of the MATLAB function f0, and you can view the help page at this website. Additionally, you can view the source code of this algorithm in the file f0.m. So, following this topic, you are now aware of the Brent-Dekker method. You are You understand that such hybrid algorithms exist and are available and have been analyzed intensively. You are aware also that the text that describes this algorithm is available for reference. Here are the references, acknowledgements, the colophon, and a disclaimer. Cheers!